Welcome to the class of Advanced Calculus and Complex Analysis. Today we are going to obtain plane area as double integral. Plane area enclosed by one or more curves can be expressed as double integral. So let R be the region, and that region we are going to find out. In Cartesian form, we are going to use this formula. It is double integration dx dy. For polar case, we are going to use this double integration formula, that is double integration r dr d theta over the region, both the cases over the region r. Suppose r is the region, we will see for different example different types of region. Suppose for this question, find the area between the parabola y square is equal to 4ax and x square is equal to 4ay is a constant. So by using the double integral, by the double integral, okay. So two parabolas are there. One is y square is equal to 4ax, another is x square is equal to 4ay. So question is, there is a region, that area we are going to find out, which is enclosed by these two curves. So for this type of questions, your first aim is to draw the graph, because from that graph we'll find out, or we'll see that what is that actually bounded region. So graphically, first of all, you have to visualize it. So the question is given in the Cartesian form. So that means our coordinates are x and y, where, so this point, that is the region, that is the origin, that is the origin O, and one parabola is given, y square is equal to 4x. These are the well-known form of the parabola. So it will be looks like in this form. It is y square is equal to 4ax. Okay, so next one is the x square is equal to 4ay. So that means it looks like in this form. X square is equal to 4ay. So from these two parabolas, which is actually enclosed or bounded this region. Okay, it is clearly showing it is the bounded region and bounded by these two parabola. So region is R. This is R. So we are going to find out this area by using the double integration. But in the question, so there is no integration symbols, but we know for the Cartesian form what is the area formula. So to do that one, before that we have to find out so O coordinates, we know it is 0 0, but for these coordinates I am giving the name A. What is the coordinate of A? It is necessary to obtain the area, so by using double integration. What is the coordinate of A? For the A point we will get it. So that means we have two curves, y square is equal to 4ax, another is x square is equal to 4ay. So you just and the two curves intersect. So that means you can do it from beginning. So it is y square is equal to, one curve is y square is equal to 4ax. So from here what you are getting, x is equal to y square by 4a. Okay, so another expression of parabola is x square is equal to 4ay. So you can substitute that x is equal to y square by 4a here. So from here we will get y square upon 4a, that whole square is equal to 4ay. Okay, so from here what we are getting? We are getting y to the power 4 minus 64 a cube y. So you can solve this one. So from here we will get, therefore we are getting y is equal to 0. Another root is y is equal to 4a. Okay. So now what is y is equal to 0? If you substitute any one of the parabola, so that means you will get x will be equal to 0. So that means when y is 0, then x is equal to 0. For that case, that means when y is 0, from any one of the relation you will get x is equal to 0. So that means it is the coordinates of O. That means it is the origin. Okay. So for another one, it is y is equal to 4a. If you substitute in any one of the relation, then you will get what is x? You will get x is equal to also 4ay or 4a. 4a. Okay. So y is equal to 4a, then x also will get 4a. So that means this is the coordinate of a. So what is the coordinate of a? We are getting 4a, 4a. What is the coordinate of O? So after solving also we are getting it is 0, 0. So two coordinates we have obtained. Now we are going to visualize. So what is the actually the double integration form with the integration. So now actually what is the area formula for Cartesian form? So you just keep it mind this graph. So here, so before going to the next slide, so let me draw a strip which is parallel to y, because we are going to do the double integration with respect to y first. So that's why we are drawing a strip which is parallel to y axis. Now you look at this strip bottom side. So bottom curve is x square is equal to 4ay, and the upper curve is y square is equal to 4ax. Okay, so that means accordingly we can write the limit for y. So limit for y will be the bottom of the strip that curved up to the upper of that strip that curved. Okay, so that is the limit for y. What is x? X is basically it is starting from 0 to a. So in the next slide I will discuss that how do you write the limit of a double integration. So what is the area? For Cartesian coordinates, we know area is equal to, so that is the double integration r dx dy. Okay. So now you can do with respect to x and with respect to y. Uh, as I have drawn that graph, and in that graph, in that region, we have drawn one strip which is parallel to y-axis. So that's why I am going to do the integration with respect to y first and next x. So it will not affect if you do with respect to x first and or with respect to y. So you will get the same result. So that means as I am going to do with respect to y first, that means I have to write the y limit. So as I told you, look at that strip. Look at the strip which is and look at the bottom curve. So that is what is for that one. That is y is equal to, for that parabola, we will get y is equal to x square by 4a. What is the upper curve? Upper curve of that strip. So that is will get y is equal to 2 root ax. So here we will get a plus minus, but we'll consider only the positive one because that curve or that region is given in the positive quadrant, in the first quadrant. That's why I am considering only the plus. And this is the limit for x. X is 0 to x is equal to 4a. So that means from lowest to up to the highest. So then simply you do the integration with respect to y. So it is the x limit, it is 0 to 4a, and here with respect to y, that means it is y, and y limits x square by 4a, upper limit to root over x. So it is 0 to 4a. It is the limit for x. Okay. So y, for with respect to y already we have completed. So with respect to x next, now you substitute for y limits. So then it is 2 root ax minus x square by 4a. So that is dx. Now you see, look at the expression. It is only in terms of x. So that basic things we have learned in the double integration from the beginning. How do you evaluate that double integration? So when you will do with respect to y, so that means you keep that x as constant. Now after substituting the y limits, we will get the expression in terms of x only. Now you can easily do the integration with respect to x and will substitute the limits for x. Okay, so that means we are getting it is 2 root a to do the integration, and x to the power 3 by 2 divided by 3 by 2 minus x cubed by 12a. We are doing the integration with respect to x. Okay, so and what is the x limit? X is 0 to 4a. So now you substitute the limit for x. Upper limit is 4a and lower limit is 0, and in each term, so x is there, that means minus of 0 term will not affect. So after substituting, and if you do some evaluation, clearly you will get it is 16 square by. So what is that area? That or what is that region? So region area, it is 16 square by 3, which is enclosed by the two parabola. One is y square is equal to 4x, another is x square is equal to 4ay. Okay, so in this way you can obtain the area, and that area is enclosed by one or more curves. For the next example, we'll see how do you find out the area by using double integration concept when the system is given in the polar form. So suppose now question is given in the polar form. So the question is, find the area of cardioid r is equal to a 1 plus cos theta. This is the question. So I am including by using the double integration. But so otherwise you can use the geometrical concept, and accordingly you can so find out what will be the area of the cardioid. But my interest, how do you find out that area? So by using double integral concept. Okay, so let us see. As I told you, for this type of questions, first of all you have to draw the graph. So graph of this cardioid, which looks like in this form. So how will you get it? So this is also very easy to draw. So this is the equation. So this is the graph of the cardioid. R is equal to a into 1 plus cos theta, where a is a constant. How we are getting? So suppose theta is equal to 0. So what is r? R is equal to 2a. So that means when theta is 0 means so on this axis, okay. So when the theta is 0, that means here. So what is r? R is equal to 2a. So this is actually 2a distance from here to here, 2a. So when theta is equal to pi by 2, so in this way you can draw the graph. Just I am giving hints. When theta is pi by 2, that means here. Okay. So what is your r? R is equal to a. r is a. That means this length is a. Okay, so when theta is equal to pi, from that relation r is equal to a into 1 plus cos theta, so you will get r is equal to 0. So theta is equal to pi this side, so r is equal to 0. That means it will come up to that origin. It will touch that origin. Okay. So and next I want to see on the negative side of a vertical axis. So when theta is equal to 3 pi by 2, so what is r? R will see r is equal to a. Okay, that means here. That means this side and this side. So both are symmetry, and here length is a and here is a, and here this length is 2a, and but here it will touch the origin for both the sides. Okay, so accordingly you can draw the graph. And what is the area of that cardioid? That means this area. This is the region R. So we are going to find out what will be the area of this region. Okay, so just now we have obtained when R is equal to, so what is that coordinate? R is equal to, so 2a. Okay, so that means you can write it, otherwise we'll see. So when already I have obtained that when theta is equal to 0, what is r and the different angles. So directly now I can write what is the area for this case. Okay, it is the double integration over the region r. It is r dr d theta. Okay, so now you can write the limits of r and theta. Okay, it is given r is there and dr d theta. So that means we'll do the integration with respect to r first. That means you have to write the r limits. So r, what is r? R is going to r. What is the lowest r? R is equal to 0. R is 0 because here there is no, so nothing is there in this side. It is 0. R is lowest is 0, and up to the highest, up to that curve, up to the curve. Okay, r lowest is 0 and up to that curve. So r is equal to a 1 plus cos theta. So you can't consider r is equal to 2a or r is equal to a. That means it will be a specific distance, because r is equal to 2a means up to here only. So up to here, but for this one, its distance is different. So there are so that means different distance you will get up to the curve. So that's why in general you have to write up to that curve r is equal to a into 1 plus cos theta. So next, what is theta limit? So theta, as it is showing in the graph, theta is 0 to theta is equal to 2 pi. Okay, so now you do the integration with respect to r, and next we'll do with respect to theta. So if you do with respect to r, so you will get theta limit 2 pi, 0 to 2 pi, and it is r square by 2, r limits 0 to a 1 plus cos theta d theta. Now substitute the limits for a. So r, so that means it is 0 to 2 pi, 0 to 2 pi, it is a square 1 plus cos theta whole square divided by 2 and d theta. Okay, so this implies, so a square by 2 you can take it outside, it is a constant, and 0 to 2a, it is, you can expand it, otherwise it will be a problem to do the integration. So it is 1 plus a plus b whole square, 1 plus 2 cos theta plus cos square theta d theta. Okay, so now term by term you can do the integration, but before that, for the third term, it is cos square theta, you have to use this, that cos 2 theta formula. So that means it is a square by 2 0 to 2a, you can write it is 1 plus 2 cos theta plus half of what is here. So this is 1 plus cos 2 theta. Okay, because if you multiply here 2 in the numerator and denominator, that means 2 cos square theta. So 2 cos square theta formula is 1 plus cos 2 theta. That means it is coming half of 1 plus cos 2 theta and d theta. Okay, so now you can do the integration term by term. So first one is 1, that means you will get theta, and next one is this one. Okay, so that means a square by 2. So first is theta, and term by term you can do. It is 0 to 2a plus 2. Otherwise at a time also you can do. It is sine theta 0 to 2 pi plus half of theta 0 to 2 pi. Okay, and next one is the cos 2 theta. So that will get 1 by 4 because already half is there outside. So that means sine 2 theta, and theta limit 0 to 2 pi. Okay, so term by term you can do, otherwise at a time. So now we substitute the limits for theta, and it is theta and sine theta. Sine theta 2 pi is 0, or sine 4 theta 4 pi also, that is 0, and sine 0 0. So just simply you substitute, then you will get the required area, that is 3 pi a square by 2. Okay, so this is the required area. So when the question is given in the Cartesian or polar form, accordingly you apply the area formula when you are getting one region which is enclosed by one or more curves. Thank you.